This video introduces latitude and longitude and shows you how you can calculate distances on a line of longitude. Any point on the Earth's surface can be located using its latitude and longitude. Lines of latitude are imaginary circles on the Earth's surface, each parallel with the equator. They are sometimes called parallels of latitude. Lines of latitude are circles of differing size, getting smaller towards the North and South Pole. Each line is labelled according to the number of degrees north or south of the equator. This means that the labelling goes from 0 degrees at the equator to 90 degrees north or 90 degrees south at the poles. Lines of longitude are imaginary circles on the Earth's surface. Each is of radius the same as the Earth. The Earth has a radius of approximately 6,371 kilometres. Lines of longitude are sometimes called meridians of longitude. The lines are not parallel as they all intersect at the north and south poles, and each of the meridians is labelled according to the number of degrees east or west of the prime meridian, 0 degrees, which passes through Greenwich in England. This means that the labelling goes from 0 degrees up to 180 degrees east or 180 degrees west. When locating a place on the Earth's surface, the convention is to give its latitude first and then its longitude. Hobart, for example, is 43 degrees south, 148 degrees east. When a journey is made between two places that are on the same longitude, that is, you're travelling north or south, the traveller would be moving on a circle of radius the same as the Earth. This is called a great circle on the Earth's surface. The arc length formula can be used to find the distance involved. So we use d equals 2 pi r times theta over 360. In this formula, r is the radius of the Earth and theta is the angular difference in latitude. Let's see how it works in an example. The worked example shows how the distance between two places on the same longitude can be calculated. One place is 50 degrees north and the other 30 degrees south of the equator. A cross-section view of the Earth is useful as it can help you to work out the angle subtended. We use the arc length formula. Theta is the angle travelled through, shown in red on the diagram. In this case, theta is found by adding together the latitudes north and south of the equator, so it will equal 80 degrees. R is the radius of the Earth, 6,371 kilometres. Once you've substituted the numbers into the formula, it's a simple matter to calculate the distance in kilometres. It's valuable to realise that as our value for the radius of the Earth is only an approximate, it's best to give final answers only to the nearest kilometre. Let's work some more examples. In this example, we are to calculate the distance between two places on the same longitude, one at 40 degrees north and the other at 22 degrees south of the equator. So we draw a cross-section diagram of the Earth and position A and B appropriately. A is 40 degrees north and B 22 degrees south of the equator. This is the formula, and theta is the total angle travelled through. So it will be 40 degrees plus 22 degrees, that is 62 degrees. Put the information into the formula. The radius of the Earth is 6371 and we can calculate the distance in kilometres. The next example is slightly different. P and Q are on the same longitude. P is 12 degrees north and Q 38 degrees north of the equator. We draw a cross-section view and position P 12 degrees to the north and Q 38 degrees to the north. Notice that the angle here is measured all the way from the equator. When substituting into the formula, theta is the angle subtended by the travel, and so in this case it will be found by subtracting the two latitudes. 38 degrees minus 12 degrees equals 26 degrees. We put that into the formula and calculate out the distance. Did you notice the difference between the two examples? In the first case, when one place was to the north and the other to the south of the equator, we ended up adding together the latitudes to find the value of theta. But in the second, where they were both on the same side of the equator, we ended up subtracting their latitudes to find theta. It's time for you to do some practice on this.